Question 7, lots of equations, lots of numbers. Equation sum answer unit will see you through this question quite well. 0 to 80 miles an hour in 1.9 seconds. Miles an hour, that looks like it's bad news. 400 meters of track, 26 seconds. Do the calculations, read the question, use ISY. Use information from the above text to calculate the average speed of the train. State your answer to 3 significant figures. Equation, distance over time for speed, is 400 meters divided by 26 seconds gives you 15.4 meters per second when it's done to 3 significant figures. If you forgot the equation, you lost a mark. If you got the significant figures wrong, you lost a mark. What's the difference between a vector and a scalar? A vector has direction and magnitude, whereas a scalar just has magnitude. Distance is a scalar, displacement is a vector. Essentially, 1 mark for mentioning direction, 1 mark for mentioning magnitude, and you lost a mark if you somehow confuse the difference between scalars and vectors. Show that 80 miles an hour is the same as 36 meters per second. Most of you did this quite well, but laid it out terribly badly, so it was almost impossible for me to work out what your sums were. You used numbers like 128,000 without explaining that was the number of meters in 80 miles, or you used 3,600 without explaining that was the number of seconds in an hour. So you finished up with the right answer, but with no real explanation as to how you got there, in which case you probably finished up with me writing units and you lost 1 mark. Calculate the average acceleration of the train. Should have been straightforward. ISY. Acceleration, change in velocity over time taken, 36 meters per second divided by 1.9 seconds gives you 19 meters per second squared. A number of you forgot to put in the equation, you lost a mark. A number of you got the unit wrong, you lost a mark. Quite a number of you used 80 miles an hour, which gave you a wrong answer of 42.1. And this would be correct at 42.1 provided you used the units of miles per hour per second, which would be a fairly complicated set of units. I don't think anyone managed that. Stick to SI units. Calculations involving kinetic energy, half mv squared. Stick in the numbers, half times 2,700 times 36 squared. When the train is moving at its fastest, gives you 1,749,000 joules approximately. Again, if you made the mistake of using 80 miles an hour, you lost a mark, but you should have got the answer 8,640,000 at that point. 3 marks, you'll have lost a mark for the sum or the answer or the unit. Question 3 was a difficult part. You had to do 4 things for 4 marks. First of all, do an MGH calculation, which got you the answer 2,160,000. Secondly, you had to point out that you appeared to need more energy than you'd actually got available. Thirdly, you need to point out, therefore, that that can't be possible because you can't just create energy from nowhere. And the 4th mark was if you suggested that perhaps the energy appeared from somewhere else. Perhaps there was some sort of a kicker on the track, perhaps there was some sort of magnetic attraction at the top, but something gave you the additional energy. Difficult to get 4, a number of people got 3 marks. Final part, why would be the explanation as to why you failed to reach the top of the incline. Essentially, some sort of additional friction on the track, high winds or insufficient lubrication, or an explanation that the acceleration mechanism was not sufficient to get the cart up to the required speed of 36 meters per second. If you talked about additional mass of passengers, that didn't get you the mark unless you explained that that would be why the acceleration wasn't sufficient. 1 or 2 of you suggested that it might have a slippery track. Of course, actually, if the friction on the track was lower than the height that the truck would get to would actually be higher, so it would be more likely to make it over the top of the incline.